Chapter 5: The Brain and Quantum Phenomenon. Entanglement shows that distance doesn't matter in the quantum world. Could our minds be connected in ways that transcend space and time? When particles are entangled, their fates are bound, no matter the distance. What if consciousness holds similar bonds, linking us in ways we've yet to imagine? Clovis. The current understanding of the brain's role in consciousness is a complex and multifaceted topic that continues to be actively researched and debated within neuroscience, psychology, and philosophy. While significant progress has been made in understanding the neural correlates and mechanisms associated with consciousness, the nature of consciousness itself remains one of the most elusive mysteries in science. In Chapter 4, we explored various theories of time, including the intriguing possibilities offered by quantum mechanics and higher dimensions. We discussed how these theoretical frameworks might suggest new ways to understand the nature of time and consciousness. Building on this foundation, we now delve into the complex and multifaceted relationship between the brain, consciousness, and quantum phenomena. This chapter aims to bridge the gap between established neuroscience concepts and speculative quantum theories, exploring how quantum processes might influence our understanding of consciousness and temporal dimensions. Here are 6 key points that represent the current understanding of the brain's role in consciousness. Neural correlates of consciousness, NCC. Neuroscientists have identified patterns of brain activity that are associated with various states of consciousness, including wakefulness, sleep, anesthesia, and altered states of consciousness. These neural correlates of consciousness provide insights into the brain regions and networks that are involved in generating and sustaining conscious experiences. Global workspace theory. One prominent theory in neuroscience is the global workspace theory, proposed by Bernard Bars and others. According to this theory, consciousness arises from the global integration of information across distributed brain networks. The brain's global workspace acts as a neural hub where information from different sensory modalities and cognitive processes is integrated and made available to conscious awareness. Neural synchrony and integration. Consciousness is thought to depend on the coordinated activity and integration of neural networks across different brain regions. Studies have shown that synchronized oscillations and dynamic interactions among neuronal populations play a crucial role in supporting conscious processing and the integration of information across distributed brain areas. Role of specific brain regions. Certain brain regions have been implicated in supporting specific aspects of consciousness. For example, the prefrontal cortex is involved in higher-order cognitive functions, self-awareness, and executive control, while the thalamus is thought to play a key role in regulating arousal and attentional processes. Disorders of consciousness. Studies of patients with neurological disorders, such as coma, vegetative state, and locked-in syndrome, provide valuable insights into the neural mechanisms underlying consciousness. These disorders highlight the importance of intact neural networks and functional connectivity for the emergence of conscious awareness. Consciousness as a dynamic process. Increasingly, consciousness is being viewed as a dynamic and context-dependent process that emerges from the interactions among brain networks, sensory inputs, cognitive processes, and environmental stimuli. The study of the dynamic nature of consciousness is advancing through approaches such as brain imaging, computational modeling, and interdisciplinary research collaborations. The potential involvement of quantum phenomena in brain function is a topic of speculation and ongoing research in the fields of neuroscience and quantum biology. While the idea of quantum processes influencing brain function remains controversial and speculative, some researchers have proposed theoretical frameworks and conducted experiments suggesting that quantum phenomena could play a role in certain aspects of neural processing and cognition. Here are some key points regarding quantum phenomena in the brain. Quantum coherence. Quantum coherence refers to the phenomenon where particles, such as electrons or photons, exist in a state of superposition, meaning they can occupy multiple states simultaneously. Some researchers have speculated that quantum coherence could occur in biological systems, including within neural networks in the brain. Quantum coherence could potentially influence processes such as information processing, synaptic transmission, and neural dynamics. Quantum tunneling. Quantum tunneling is a phenomenon where particles penetrate through energy barriers that would be classically forbidden. In the context of neuroscience, quantum tunneling has been suggested as a possible mechanism for processes such as neurotransmitter release at synapses, where molecules must traverse barriers to cross the synaptic cleft. Entanglement. Quantum entanglement occurs when particles become correlated in such a way that the state of one particle is dependent on the state of another, even when they are separated by large distances. While the occurrence of entanglement in biological systems is still debated, some researchers have proposed that entanglement could potentially be involved in long-range communication and synchronization within the brain. Quantum biology. Quantum biology is an interdisciplinary field that explores the potential role of quantum phenomena in biological processes. While most biological systems are governed by classical physics, there is increasing evidence that certain biological processes, such as photosynthesis and avian navigation, may exploit quantum effects for efficient energy transfer and sensory perception. Some researchers have speculated that similar quantum effects could be relevant to brain function and cognition. Quantum coherence is a fundamental concept in quantum mechanics that describes the phenomenon where particles, such as electrons or photons, exist in a state of superposition, meaning they can simultaneously occupy multiple states or locations. Coherence arises from the wave-like nature of particles in the quantum realm and is a key feature of quantum systems. One prominent hypothesis linking quantum coherence and consciousness is the orchestrated objective reduction, OR theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. According to OR theory, quantum coherence and objective reduction events occurring within microtubules are proposed to play a role in consciousness by influencing neural dynamics and information processing in the brain. These quantum processes are suggested to be responsible for the integration of information across large-scale brain networks, leading to the emergence of coherent conscious experiences. Orchestrated objective reduction, OR theory, posits that quantum processes within microtubules, structural components found in neurons, play a role in the emergence of consciousness. While OR theory does not directly address consciousness, becoming entangled in the traditional sense of quantum entanglement, it does propose that quantum coherence and objective reduction events within microtubules contribute to conscious experience in several ways. Quantum coherence, OR theory, suggests that quantum coherence, where particles exist in a state of superposition, occurs within microtubules. This quantum coherence allows for the simultaneous processing of multiple pieces of information at the quantum level. Objective reduction. Objective reduction refers to a proposed mechanism by which quantum states collapse or reduce to classical states due to gravitational effects in spacetime. According to OR theory, objective reduction events occur within microtubules and are influenced by quantum processes. Consciousness emergence. The quantum processes within microtubules, including quantum coherence and objective reduction, are proposed to influence neural dynamics and information processing in the brain. These quantum processes are suggested to contribute to the integration of information across large-scale brain networks, leading to the emergence of coherent conscious experiences. In quantum mechanics, superposition refers to the principle that quantum systems can exist in multiple states simultaneously until a measurement is made, at which point the system collapses into one of the possible states according to the probabilities determined by its wave function. The wave function is U. Superposition is a fundamental aspect of quantum mechanics and is indeed associated with the behavior of particles at the quantum level. When particles are in a state of superposition, they can exhibit a wide range of possible behaviors and properties simultaneously. This includes the potential for particles to become entangled with one another, where the states of two or more particles become correlated in such a way that the state of one particle is dependent on the state of another, even when they are separated by large distances. So, in the context of quantum coherence and superposition, it is indeed possible for particles to become entangled with one another. In fact, Entanglement is a natural consequence of the principles of quantum mechanics and can arise when particles interact in certain ways, such as through the emission or absorption of photons, or through other quantum processes. Entanglement in our brains might help transitions through temporal dimensions and be essential to our experienced reality.